I'm Claude Shannon, a mathematician here at the Bell Telephone Laboratories. This is Theseus. Theseus is an electrically controlled mouse. He has the ability to solve a certain class of problems by trial and error means and then remember the solution. In other words, he can learn from experience. Like his classical namesake, Theseus has the problem of finding his way through a maze. His objective is the goal here in the corner. He is now exploring the maze using a rather involved strategy of trial and error. As he finds the correct path, he registers the information in his memory. Later, I can put him down in any part of the maze that he's already explored, and he'll be able to go directly to the goal without making a single false turn. Of course, solving a problem and remembering the solution involves a certain level of mental activity and something perhaps akin to a brain. A small computing machine serves Theseus for a brain. Of course, Theseus himself is much too small to contain even a small computing machine. And we have placed the brain cells, if you like, of Theseus behind the mirror here. This is a bank of relays, telephone relays. And the job they do for Theseus is similar to the job they do in your dial telephone system. Each time you use your telephone, the dial system has to remember the number that you dialed, then guide your call through the maze of connections, the thousands of separate lines in a dial switching office. In a fraction of a second, it must find a trunk line free to carry your call. It also has to remember in itself what sequence of steps are necessary to make the connection for you. Here at the Bell Telephone Laboratories, we're concerned with improving your telephone system, making it work better to give you more efficient service. One of our continuing projects is on dial switching. Incidentally, the things we learn for the telephone system have other applications, too. We can use these telephone relays to build computing machines, machines that can solve mathematical problems in a few minutes that would otherwise take many days to solve. We at Bell Labs also use this knowledge to build gun director equipment for the armed forces. The many factors which affect the aiming of guns and guided missiles are computed and applied by these machines in fractions of a second. Theseus is a simple demonstration of some of the things we can do with telephone relays. He's now had a chance to find his way through the maze, and there he's reaching the goal. Now let's see how well he remembers what he's learned. Theseus is capable of other types of intelligent behavior. He can add new information and adapt to changes. If the entire maze or part of it, for example, is changed, he will explore the changed area, replacing the old information that's no longer of value by the new information that he's just learned. Here, let me show you what I mean. Suppose I change the maze around a little bit. Let's say I take this partition and move it over here. And suppose I move this one over here. There are over a million different ways you can set up mazes on this board. Now we'll take the mouse and put him back in the same starting point, and let's see what he does. He's replacing the old obsolete information with what he's now learning about this new situation. Those copper whiskers of his tell him when he's up against a wall and has to try a different direction. Now he's through the change section, and his memory is correct for the rest of the way to the goal. For a bar magnet mounted on 3 wheels, Theseus is rather agile. Here again, though, it isn't the mouse that does the actual work. The motors and mechanism that really move him around are mounted underneath the maze floor. Here, let me show you. The mouse is actually moved by this electromagnet, which can move in a carriage in two different directions, driven by a pair of motors here and here. The position of the mouse is sensed by the machine in terms of a number of reed switches, which are located under the different squares of the maze. If the mouse is brought into one of the squares, it closes the appropriate reed switch. This gives a signal to the electromagnet to move over to a position underneath that square, and then the relay circuit takes over the control of the electromagnet and thereby the mouse. When Theseus is exploring a maze, he rotates his trial directions for any square in a clockwise manner, north and east and south and west, until he's able to escape from the square. He also takes account of the direction by which he entered the square and what his previous knowledge from the last time he was there. A theorem from that branch of mathematics known as topology guarantees that his method of exploration will eventually solve any possible maze. Of course, not only means that Theseus can solve any problem that can be solved. Like the rest of us, he occasionally finds himself in a situation something like this.